All right, let's get ready for another deep dive. And this time, we're going big, like really big. We're tackling the sun.
We are.
Our jumping off point for this is a YouTube documentary called, let me check my notes, The Sun Secrets and Facts.
Catchy.
Right. Yeah. I think it's going to be a pretty illuminating journey, to say the least.
Illuminating is putting it mildly. We're talking about the powerhouse of our solar system, the thing that makes life on Earth even possible.
Exactly.
Yes.
And for something so central to, well, everything, it's amazing how many mysteries the sun still holds.
Absolutely.
Like even the basics. How does it generate all that energy, and how do those processes, lead to things like solar storms? The documentary makes it clear those can have a big impact on us down here.
It's a complex system, no doubt. The documentary mentions some pretty mind-blowing figures, like a core temperature of 27 million degrees Fahrenheit. And it's been around for over 4 billion years. But even those massive numbers don't really capture how intricate everything is inside the sun.
So true. It's so much more than just a giant ball of fire in the sky.
So where do we even begin trying to understand something that vast and complex?
Well, scientists have come up with some pretty clever methods. One that comes to mind is helioseismology.
Helioseismology.
Yeah. It's basically using sound waves to create a picture of the sun's interior. Like a sonogram, but for a star.
Hold on, we can actually see inside the sun. That sounds like something straight out of Star Trek.
It's pretty wild, right? But by studying these solar sound waves, scientists can map out the different layers of the sun, from the core all the way out. And that core, that's where all the action is, the source of the sun's power. It all comes down to nuclear fusion.
Okay, so we're talking about hydrogen atoms fusing to create helium. And that releases a ton of energy, right? I've heard it compared to billions of hydrogen bombs exploding every second. Is that a fair analogy? It might sound a bit dramatic, but essentially, yeah. The conditions in the sun's core are just insane. Temperatures hit 15 million degrees Celsius. The pressure is unimaginable. It forces those hydrogen nuclei to overcome their natural repulsion and fuse together. And that fusion process, that's what fuels the sun, bathes the whole solar system in light and heat.
It's kind of mind-boggling. The sunlight we're feeling right now, today, those photons started their journey in the sun's core millions of years ago.
Millions, yeah.
Talk about a commute.
And a rough one, too. Those photons, those little packets of light and heat, they have to go through a lot to get from the core to the surface. First, they have to navigate the radiative zone.
Radiative zone.
It's a super dense region full of plasma. And those photons, they just bounce around in there, constantly getting absorbed and re-emitted like a cosmic pinball machine.
So it's not a straight shot out of the core then. How long does this radiative zone detour take?
Oh, get this. It takes those photons an estimated 100,000 years to get through that zone.
100,000 years.
100,000 years.
Wow. That's like practically forever. So the sunlight hitting us today, those photons, they could have been generated back when Neanderthals were roaming Earth. It really puts things in perspective, doesn't it?
It does. And the journey doesn't end there. Once they escape the radiative zone, they hit the convective zone. Think of it like a giant boiling pot. The plasma's churning, circulating heat up to the surface.
It sounds like the sun is much more dynamic than most people realize. It's not just some static ball of fire just hanging out in space.
Oh, absolutely not. It's constantly changing, super active. And one of the main drivers of all this activity, the sun's magnetic field, which, as the documentary pointed out, is a big factor in those crazy solar storms we mentioned.
Right. They talked about the sun's differential rotation, how it spins faster at the equator than at the poles. That creates the magnetic field, right?
That's key. It sets up all kinds of shear and friction in the plasma. It basically twists and tangles those magnetic field lines, like a rubber band about to snap.
Uh-oh. And when those magnetic field lines snap?
That's when we get solar flares. Sudden bursts of energy, huge amounts of radiation and light. And sometimes those flares come with an even bigger guest star, coronal mass ejections, or CMEs for short.
CMEs. Those are the ones that can really mess things up for us here on Earth, right?
They can.
Millions of tons of charged particles flung out into space at insane speeds.
Yep. And they come from the sun's corona. That's its outer atmosphere, which, by the way, is another mystery altogether. It's actually hotter than the sun's surface, which doesn't make a lot of sense.
Right. How can something further away from the heat source be hotter? That seems backwards.
It does. The documentary mentioned theories about high-speed plasma jets carrying heat up into the corona.
So have scientists figured out this coronal heating mystery yet?
They're getting closer. Thanks to missions like the Parker Solar Probe, that thing's actually flying through the corona. gathering data on what's going on in that crazy region. It's a real game changer, giving us never-before-seen looks at the sun's outer atmosphere.
Okay, so we've got this super odd corona powered by some mysterious mechanism, and then these massive CMEs erupting from it, some of them aimed right at us. Sounds like a recipe for disaster.
It can be, yeah. We'll definitely dig into those potential consequences. But first, I think it's important to understand the sun's, well, moods. It's not always in a stormy mood. It goes through cycles. And knowing where we are in that cycle is key to predicting space weather events.
Okay, so tell me about these cycles. The sun has, like, a cosmic calendar it follows or something.
It does. It's called the solar cycle. An 11-year cycle that goes from periods of high activity, known as solar maximum, to periods of relative calm, called solar minimum.
So how do we know when we're approaching solar maximum? What are the signs?
One of the most obvious. Sunspots.
Sunspots?
Yeah, those darker patches you can see on the sun's surface, they might look cooler, but they're actually regions of intense magnetic activity, and often they're the breeding ground for those solar flares and CMEs.
So lots of sunspots.
Yeah.
Bad news for us.
It's not that simple. More sunspots usually do mean more solar activity, but it's the specifics of those magnetic fields that really matter. How tangled they are, how unstable they seem. Those are the clues that help us predict when a solar flare or CME might erupt.
So it's a bit like predicting hurricanes then. We're not just looking at wind speed, but also at barometric pressure, storm surge potential, all the factors that determine the impact.
Exactly. And just like with hurricanes, we're always working to improve our forecasting models, using data from observatories on Earth and missions in space, all to get better at predicting what the sun's going to do next.
The documentary did mention some pretty amazing technology being used to study the sun. What stood out to you?
Honestly, the Parker Solar Probe. That thing's insane. It's flying closer to the sun than anything we've ever sent before. It's dealing with crazy heat, intense radiation, all to get us data on the solar wind and how the corona works.
That's wild. It's like sending a probe into a volcano.
I know, right? And the data it's sending back. It's changing everything we thought we knew about the sun. We're learning about coronal heating, how the solar wind forms, stuff we could only dream about before.
It makes you realize how much we still don't know about our own star. So much more to explore, so much more to learn.
Absolutely, and that's what makes it so exciting, right?
Definitely. But I gotta say, even with all this incredible tech, it sounds like we're still at the mercy of the sun's whims, at least to some extent. And the documentary mentioned some close calls, times when Earth just barely avoided a major solar storm. I'm dying to hear more about that.
Oh, yeah, there have been some scary moments. Like, remember that solar storm back in February 2011?
I don't.
Wow, it was huge. A powerful CME that luckily just missed Earth. If it had hit us head on, well, let's just say things would be very different right now.
Yikes.
That wasn't even the first close call. There was the Quebec blackout back in 1989. Millions of people lost power because of a solar storm. It's a wake-up call. Shows just how vulnerable all our tech is to these events.
It does. It's kind of unsettling to think about. But we do have Earth's magnetic field, right? That acts as a shield.
It does. It's our first line of defense. And it does a pretty amazing job of deflecting most of the harmful radiation coming from the sun. But a really big event, something like the Carrington event back in 1859.
Okay, now you have to tell me about the Carrington event. What happened?
Okay, imagine this. A superstorm so powerful that it caused auroras to be visible as far south as Cuba. And telegraph systems all over the world went haywire. Some even caught fire.
No way. And that was back in 1859, before we were so reliant on technology. What would happen if something like that hit us today?
It could be catastrophic. Widespread blackouts, communications down, GPS knocked out, air travel disrupted. We're talking trillions of dollars in damage, potentially. It's the kind of scenario that keeps space weather experts up at night.
Okay, now I'm really starting to feel a little uneasy. This deep dive has definitely given me a new respect for the power of the sun. It's life-giving, sure, but it can also be incredibly destructive, a force to be reckoned with.
It's a delicate balance, isn't it? Power and fragility all wrapped up in one giant cosmic package.
And understanding that balance, figuring out how the sun works.
Yeah.
It's critical for our future here on Earth.
It is.
That's what makes this whole exploration so fascinating. We've only just scratched the surface here. I can't wait to dive even deeper into those mysteries. What else does the sun have in store for us?
Well, one thing that really stood out in the documentary was that whole idea of the solar cycle, how it controls the ups and downs of solar activity.
Yeah, it's like the sun has its own rhythm, its own heartbeat almost,
Huh?
and we're only beginning to figure out how it all works.
Exactly. It's not just about the big, flashy events like solar flares and CMEs that make the news. There's this whole intricate dance of magnetic fields happening behind the scenes, driving the entire cycle.
You're talking about that magnetic flip, right? The one that happens every 11 years. It blows my mind to think that the sun's entire magnetic field actually flips poles.
It's wild, isn't it? Scientists are still working out the details, but we're getting closer to understanding how it happens. And a big part of that progress is thanks to the Solar Dynamics Observatory, SDO for short.
Oh yeah, SDO. That's the one that's basically staring at the sun 24/7, capturing those insane high-resolution images, right? I've seen some of those pictures. They're mesmerizing.
They are, but they're more than just pretty pictures. They give scientists mountains of data. We can actually track how those magnetic field lines on the sun's surface move and change over time.
So it's like having a front row seat to the sun's magnetic ballet. And by watching this ballet, we can start to get a better idea of when those big explosive finales are going to happen.
Exactly. We're starting to see patterns emerge, links between how those magnetic fields are arranged and the chances of solar flares and CMEs happening. It's like cracking the sun's secret code.
And the better we understand that code, the better we can prepare for those storms.
Yeah.
Right? And speaking of a preparation, the documentary did mention some of the work being done to protect our technology from all this.
Yeah, it's a multi-pronged approach. Hardening our power grids to withstand those surges of energy, developing early warning systems so we have more time to react.
Because, as we saw with that Quebec blackout, a major solar storm hitting Earth, that's not something we want to mess with.
Not at all. We're talking potential disruptions to everything. Communication networks, GPS satellites, air travel. It's a serious issue.
And it's not just about protecting our tech. It's about understanding how the sun impacts our planet on a fundamental level.
That's a great point. We tend to think of the sun as this distant object in the sky, but it's so much more than that. It drives our climate, it shapes our weather patterns, it even influences our atmosphere.
You're talking about things like the aurora borealis, right?
Yeah.
The northern lights, those beautiful curtains of light dancing across the sky.
Exactly. And that's just one visible example of the sun's influence. The documentary talked about research into how solar activity can affect Earth's upper atmosphere, messing with radio communications and even satellite orbits.
It's crazy to think that something 93 million miles away can have such a big impact on our world.
It really highlights how interconnected everything is in our solar system.
Absolutely.
Yeah.
And that interconnectedness, it goes way beyond our solar system. The sun's our closest star, but it's just one of billions in our galaxy. And by studying it, we're learning about how stars work all across the universe.
That's right. It's like we have this cosmic Rosetta Stone helping us unlock the secrets of how stars evolve and change. Which brings us to a topic I find super fascinating: the search for life beyond Earth.
Ah, yes. The big question. Are we alone?
Exactly. And the documentary touched on how understanding the sun actually helps us in that search.
Really?
Think about it. The sun is our model. It's how we understand how stars work. And by studying other stars, we're discovering planets orbiting them, planets that might have the right conditions for life.
Right. We're looking for planets in the habitable zone, that sweet spot where the temperature's just right for liquid water to exist. Because as far as we know, water's essential for life as we know it.
Exactly. And while we haven't found definitive proof of alien life yet, the search is heating up, driven by that tantalizing possibility that we're not alone.
Can you imagine knowing that life exists somewhere else out there? Even if it's just microbial life, it would completely change our understanding of our place in the cosmos.
It would be a huge deal. And it all comes back to understanding our own star, the sun. We're lucky to have it.
It does make you wonder, though, what other secrets is the sun holding? What other discoveries are waiting for us out there?
Well, there's one pretty significant event in the sun's future that we haven't talked about yet, something that's going to have a big impact on Earth and the whole solar system, really.
Okay, now you've got my attention. What are you talking about?
The sun's eventual death. It's not going to be around forever, you know?
Wait, the sun's going to die. I knew it couldn't last forever, but I guess I never really thought about it.
It's the fate of all stars. And the sun's death won't be sudden. It'll be a gradual transformation, a cosmic ballet that takes billions of years to unfold.
Okay, so paint me a picture here. What does this transformation look like? Does the sun just kind of fade away?
Not quite. It actually gets bigger, much bigger. The documentary called it the sun's red giant phase. It sounds kind of poetic, doesn't it?
Red giant, huh? So it turns red and balloons up. I'm guessing this isn't good news for Earth.
You're catching on quickly. As the sun burns through its hydrogen fuel, its core shrinks, which causes its outer layers to expand. Like a lot. In fact, it's predicted to engulf Mercury, Venus, and possibly even Earth.
Engulfed by the sun. That's a pretty dramatic way to go. What about the rest of the solar system? Are all the planets doomed?
The outer planets will probably survive, but their orbits will get messed up by the sun's stronger gravity. It'd be pure chaos out there.
So Earth gets swallowed up. The outer planets go for a wild ride. But what happens to the sun itself? Does it just keep expanding forever?
There's a limit. Eventually, it starts shedding those outer layers, creating this beautiful glowing cloud of gas and dust called a planetary nebula.
A planetary nebula. Sounds almost peaceful, like a cosmic recycling project.
In a way, it is. The sun's death throes will actually seed the surrounding space with elements that could eventually form new stars and planets. It's a cycle of cosmic creation and destruction.
Okay, so that's the outer layers. What about the sun's core? What's left after all the drama?
What remains is a white dwarf. It's super dense, incredibly hot. Think of it like the sun's ember, slowly cooling over trillions of years.
So no more nuclear fusion, no more light and heat, just a fading ember in the vastness of space?
Pretty much. The sun's reign comes to an end, leaving behind this silent, ghostly remnant.
Wow, what a story. It makes you appreciate the sun we have now, knowing that one day it'll be gone.
It really does. But hey, let's not get too bummed out about the sun's eventual demise. We've got billions of years before that happens.
True. And in the meantime, there's plenty of solar activity to keep us busy. Speaking of which, the documentary mentioned some really fascinating things about solar storms, like how do we even know they're coming? What are the warning signs?
Well, we talked about sunspots earlier. Those are a big clue. Scientists are always monitoring the sun, looking for those dark, magnetically active regions.
So more sunspots, higher chance of a solar storm. Is it that straightforward?
It's not quite that simple. While more sunspots generally do mean more solar activity, it's the details of those magnetic fields that really matter. How they're interacting, whether they're tangled up, showing signs of instability.
Ah, okay. So it's not just about the quantity of sunspots, but the quality, so to speak.
Exactly. We need to look at the bigger picture. Are those magnetic fields ready to snap? Those are the signs that tell us a solar flare or CME might be on its way.
So kind of like forecasting a hurricane, we're not just looking at wind speed, but also at barometric pressure, storm surge potential, all those factors that give us a better sense of the impact.
Perfect analogy. And just like with hurricanes, we're constantly refining our forecasting models, using data from observatories on Earth and missions in space to improve our predictions.
Speaking of space missions, the documentary highlighted some pretty incredible tech being used to study the sun. What were some of the standouts for you?
For me, it was the Parker Solar Probe. That thing is truly pushing the limits. It's flying closer to the sun than any mission before, withstanding extreme temperatures and radiation to collect data on the solar wind and the corona.
It's like sending a probe into the heart of a volcano. Mind-blowing.
It is. And the data it's sending back is revolutionizing our understanding of the sun. We're learning about things like coronal heating and how the solar wind forms in ways we never thought possible.
It's amazing to think how much we still don't know about our own star, how much there's left to explore and understand.
And that's the beauty of science, isn't it? It's a journey. There's always something new to discover, something new to unravel.
Well said. Well, on that note, I think it's time to wrap up this incredible deep dive. But before we do, what are your final thoughts? What really stood out to you from this exploration of the sun?
What strikes me most is the sun's duality. It's this life-giving force, absolutely essential for our planet. But it also has the power to disrupt our lives in a big way. It's a reminder that we exist at the mercy of forces much greater than ourselves.
That's a humbling thought.
Mm-hmm.
And it really highlights how important it is to understand and respect the sun for our own survival and for the sake of scientific knowledge.
Well said. And hopefully this deep dive has sparked a little curiosity in our listeners, a desire to learn more about this incredible star that shapes our little corner of the cosmos.
It's funny, we started this deep dive talking about the sun's power, how it can cause all sorts of trouble with solar storms. But then we learned about its eventual end, the whole red giant thing. That really puts things in a different light, doesn't it?
It does, yeah. It raises some big questions. If we know the sun's lifespan is limited, that its energy will eventually run out, how will humanity adapt?
Yeah, that's not just science fiction anymore. It's a real challenge that future generations might have to face.
It really forces us to think long term, on a scale that's hard to even grasp. I mean, the sun's lifespan, it's a reminder that nothing lasts forever, not even us.
It is humbling, that's for sure,
Yeah.
but also a little scary. What are some of the scenarios scientists are thinking about when it comes to the sun's, grand finale?
Well, the documentary mentioned the possibility of the sun expanding so much that it swallows the inner planets, Earth included.
Whoa.
If that happens, it's game over for life as we know it, unless we figure out a way to move to another planet, or maybe even another star system.
I'm talking about a cosmic eviction notice.
Yeah.
But even if we somehow dodge that fiery fate, wouldn't the sun getting dimmer have a huge impact on the rest of the planets?
Oh, absolutely. The outer planets would get a lot colder, even more frigid and inhospitable than they are now. It would basically reshape the whole solar system.
It's a pretty bleak picture. Is there anything we can do about it? Or are we just stuck waiting for the inevitable?
Well, giving up isn't really an option, is it? I think this knowledge, as unsettling as it might be, can actually push us to innovate.
You're saying that knowing our time on Earth is limited might inspire us to become a true spacefaring civilization, capable of traveling to and living on other worlds.
Exactly. We're already seeing progress in areas like reusable rockets, 3D printing for building habitats in space, even the search for other planets that could support life.
It's a bold vision, but it doesn't seem impossible anymore.
And don't forget about harnessing solar energy on a much larger scale. The documentary even talked about building giant solar collectors in space. Imagine that, capturing the sun's energy and beaming it back to Earth.
So even as the sun's natural energy output decreases, we could find ways to make up for it, become more efficient at capturing and using what it does provide.
It's definitely a possibility, and it shows how important it is to keep investing in renewable energy research and development.
Right. We might not be able to change how stars evolve, but we can definitely have a say in how we adapt to it.
Exactly. I think that's one of the biggest takeaways from this whole deep dive. It's not just about understanding the sun as this object in the sky. It's about understanding where we fit in the grand scheme of the cosmos, and recognizing that we have a responsibility to take care of our planet and make sure our species survives.
It's a powerful message, and one that I hope sticks with our listeners. This has been an incredible journey, from the sun's fiery core to its eventual demise and everything in between.
It really has. It's been great exploring this with you and with all our listeners out there.
We hope you've enjoyed this deep dive into the wonders and mysteries of the sun. Maybe you've come away with a new appreciation for that giant ball of plasma that makes life on Earth possible.
Maybe it's even inspired you to look up at the night sky with a little more wonder, to think about the vastness of the universe and our place in it.
And who knows, maybe one day, armed with the knowledge and inspiration we've gained from studying our own star, humanity will set out to explore the cosmos, to find new homes among the stars.
Until then, keep exploring, keep asking questions, and keep looking up. The universe is full of amazing things waiting to be discovered. As I have an